Hello, this is Kendall Rankin, and I will be solving problems number 2 and 3 on the interactive learning assignment. So problem number 2, we're given this chemical equation, but it's not balanced, so we must balance it using algebra. So first what I'm going to do is write all the elements underneath of this yield sign so we can compare the number of moles and we can also compare the charges. So we have iron on both sides, hydrogen, nitrogen, and oxygen. So for iron, on the left side there's 1 mole, on the right side there's 1 mole, but the charges are different, so that can also cause little complications. And then for hydrogen, there's 1 mole and 2 moles, and nitrogen there's 1 mole, 1 mole, and oxygen has 3 and 1. So we can see that this is not balanced, and therefore we must balance it. So the first thing I'll do is I see that there are 3 oxygens on this side, or there are actually 2 oxygens on this side, and there are 3 oxygens on this side. So in order to make there be 3 oxygens on the right side, I can put a 2 in front of this hydrogen, and that will give me two oxygens and plus 1 oxygen, which equals 3 oxygens. So now there are 3 oxygens. But then that causes some complications with the hydrogen. So instead of there being 2 moles of hydrogen, there are now 4 on the right side. So that means we must add a coefficient of 4 to this side, so that now the hydrogens and the oxygens are balanced. So 4. Okay. And now if we look at the irons, we can see that they have different charges. So the iron on the left has a 2+, and the iron on the right has a 3+. The total charge on the left side is 5+. The total charge on the right side is 3+. So that's not balanced either. So we can say that this will be x. The coefficient will be x for the iron. So to solve for the coefficient of iron, we know that it has a 2+ charge times x. So however many moles of this, it'll be times x. And then you have a +3 charge resulting from the other 2, because this will give you a 4+ charge, and this will give you a 1-, so you get 3. So 2x plus 3 equals the total charge on the left side. So on the right side, it has a 3+ charge, and then the only thing that gives it the charge is the iron, so you can just do 3x. So then if you set these two equations equal to each other, 2x plus 3 equals 3x, you find that x equals 3. So the coefficient in front of the irons, to make it balance, make the charges balance on both sides, is 3. So this is the final equation: 3 iron 2+ plus 4H plus nitrate yields 3 iron 3+ plus nitrous oxide plus 2 moles of water. Now on to the next problem, which is problem number 3. You have 25 milliliters, so V1 equals 25 milliliters of 0.5 molar NaOH, so the molarity 1 equals 0.5 molar. And then it neutralizes 35 milliliters of monoprotic acid, so you have the V2, which is 35 milliliters, and M2, which is our unknown. So if we use the equation M1V1 equals M2V2, we can plug in everything, and we have everything except for the molarity of the monoprotic acid. So we can solve for that. And you don't have to change the volume to liters because the units will cancel in the end. So we have M2, 35. And then you can solve for M2, and that will give you, 1 second, get the calculator. Okay, so M2 equals so the molarity will be 0.357, and then with sig figs, it'll be 0.4 molar.